In this video, we'll be using our double angle identities to simplify expressions. Our first example is to simplify 2 cosine squared 5x minus 1. Now this expression looks like our cosine 2a identity. Notice we have 2 times a cosine squared, and then some argument, and then minus 1. In this case, a is equal to 5x. So it looks like cosine 2a equals 2 cosine squared a minus 1, where a is equal to 5x. So if a is equal to 5x, we can write this left side as the cosine of 2 times 5x, which means then that we have the cosine of 10x. All right, our next example, we have the sine of 165 degrees times the cosine of 165 degrees. So we have sine of an angle times cosine of an angle. This looks like this first double angle identity. So let's write that down by our problem. So the only difference between this expression that we have to simplify and this right side of the identity is this 2. So I'm going to multiply both sides of this identity by 1/2. So I have on the left side 1/2 times the sine of 2a, and then on the right side I have 1/2 times 2 sine a cosine a. Well, these cancel, and now I have 1/2 sine 2a equals sine a cosine a, and I want to compare this right side with the expression that we're given. And it looks like a is going to be 165 degrees. So our expression then becomes 1/2 sine 2 times 165. So this is 1/2 sine, and the product here is 330. And that's one of our special angles that we can get a value for. 330 degrees is 30 degrees off of a complete revolution. So it's a reference triangle that looks like this. 330 is around that way. And we know that on this reference triangle across from the 30 is 1. Across from the 60 is a root 3, and the hypotenuse is 2. And then anything below the x-axis is going to be a negative. So now I can get my sine of 330 of 1/2 times, and then the sine of 330 then will be opposite over hypotenuse, so that's a negative 1/2. So we have the product here is a negative 1/4.